Okay, 1 because he watches it. And I don't even pay him. I just make dinner. All right. So we were talking about unit rate. We're going to switch to talking about how to apply the proportions that we talked about before. So we talked about proportions in the last class. A proportion meaning a comparison basically between two fractions, right? Between two ratios. And you solve it using cross multiplication. One of the most common ways that we apply that is in similar figures. So before we start talking about this, let's define a couple terms. So we have right here two similar figures. What are these polygons? They are called triangles. You know it's a triangle because it has how many sides? 3. 3. That's immortalized on YouTube now. All right, so there are 3 sides on a triangle. There are 3 sides on a triangle. It has 3 angles. That's why we say tri, like a tricycle has 3 wheels. Okay, this is called triangle ABC, and this is triangle DEF. All right, now, a similar figure means that it's exactly the same shape, but it's not necessarily the same size. So for instance, triangle ABC is a right triangle. So is triangle DEF. So they are the exact same shape, but triangle ABC is bigger. Okay? Now, if it's similar, that means it's bigger on a in a proportional way. All right? So we're going to use that to figure out missing sides in just a few minutes. Corresponding sides and corresponding angles. Does anyone know what the word corresponding means?
I heard it and I forgot.
Okay, that's okay. So you've heard it before.
The same, like B is a corresponding angle, or BC is a corresponding angle to E.
Okay, very good. So what Daniel said is BC, like right here, this would correspond to EF. So taking what he just said, he's correct. Can anyone give me kind of like a definition or a description then? What would corresponding mean? If BC corresponds to EF, not necessarily equal to, but those are the ones that are similar. They're in the same spot. So like B is in the same spot as E in this smaller triangle. So the ones that correspond, they kind of go together. So corresponding is like they go together. This one corresponds to this one. So we would say B corresponds to E, C corresponds to F, so then A corresponds to D. Very good, because those are the ones that are in the same spot. So we would say those are the ones that are similar, which is what Marina said. They're similar to each other, right? And that's true, okay? So B is similar to side E, A is similar to side D, and C is similar to side F, which means when we're looking for proportions, those are the ones that have to go together. So we have these two triangles here, but now instead of having letters, I have numbers on them, except for which one? D. So I've got a missing side. So we're going to try to figure out how could we use a proportion to find this missing side. So we've got the bigger triangle to the left, and then the smaller triangle to the right. And I know that you guys can look at it and mentally do it, but how could I set up a proportion that would help me figure this out? Because you're not always going to be able to do it mentally. So we could say 9 over 12, but that won't really help me. The reason 9 over 12 won't help me is because does that involve letter D? No. If it doesn't involve D, am I going to be able to find D? No. So I don't want to use 9 and 12. I can use 9, but I also have to use which one? 3. And then I also have to use, nope, 15 and D. Why? Why are those the 4 that I want to use? I need to use the variable, otherwise I can't solve for it, right? So I need to use that one. Now, 12 and 4, I could use also, I could set up a 3-chain proportion. I just don't need to. So the proportion I'm going to set up is 9 goes with which one? 3. So I'm going to put 9 over 3. And then 15 goes with D. So I'm going to say equals 15 over D. And then how would I solve that? Cross multiply. So I'm going to do 3 times 15 and 9 times D. What's 9 times D? 9D. And then what's 3 times 15? 45. How would I finish? Those are gone, so D equals 5. All right, how many of you guys looked at this right away and knew that D was 5? I heard like 10 people say it. How do you know that?
I'm smart.
Yes, true. Okay, how else? How did you know that before you even did it? Isabel? Yeah, exactly. So to go from 9 to 3, you have to divide by 3. So to go from 15, if you divide by 3, that gives you 5. So what you guys did, instead of setting up a proportion, what you guys did was in your head, you found what's called the scale factor. And scale factor basically means how much you multiply or divide by. The key here is that if there's similar figures, what that means is every one of them is multiplied or divided by the same number. And that's why it's a scale factor. So every one of these would be divided by 3 to give you the corresponding sides. Okay? This does not work if they're not similar. Because when we say they're similar, that means they're proportional, which means every one of these is divided by the same thing. Or every one of these is multiplied by the same thing. All right? We multiply if the shape is getting bigger. We divide if the shape is getting smaller. So since this shape is getting smaller, we divide. So these are the two ways you can do it. You can either figure out the scale factor, or you can set up a proportion. Now, how many people think this is shorter? It is. It's definitely shorter. All right? I consistently will set up proportions because this one worked out really neatly, right? But what if it were like this? Or what if it were like this? What if this were 5 and this were x? What's your scale factor? What do you divide 12 by to get 5? What do you divide by to get from 12 to 5? You can, but what kind of number is it going to be? It's going to be a decimal. So here, a proportion makes more sense because it's easier to see what you get when you're doing a proportion. So I'm looking at this, and I want to figure out what proportion I want to set up. Now, if I'm telling you guys again, if I always try to point out to you like the common mistakes that people make, the mistake people make here is they don't line up the right sides. So when you're setting up your proportion, you set it up wrong. So let's take a look at this, and let's figure out what sides go together. So the 12 goes with the 5. And then which other one do I need to use? 7 and x. Why is it 7 and x? Why don't I use the 18? I don't need it. It's not the one I'm trying to figure out, right? So it's just extra information. So how many of you guys have seen math problems before where they throw in extra numbers just to throw you off? Yeah, like they'll be like, a truck was driving 55 miles per hour down Highway 45 and the temperature was 86 degrees. How far could it go in 4 hours? Do you need the temperature? No, so why do they put it there? Yeah, because they're hoping to make you make a mistake, right? So this is like your temperature. You don't need that 18. It's just there to throw you off. So you want to line up the ones that you will use. So what did I do to help myself line that up? I underlined the 12 and the 5 one time, and then the 7 and the x 2 times because those go together. It's similar to when I was combining like terms and we underlined like everything with the same variables once, everything with the same variables with 2 lines. Like that's how I organize this so I can set up my proportion. So then what's my proportion? 12 over 5 equals 7 over x. So then what would I do? Cross multiply, which is going to give me what? Good. And how would I finish? Divide by 12, and you end up with x equals 2 and 11 over 12, or whatever decimal. I don't know what decimal that is. So 2.91. So 2.9. All right, we'll call it 2.9. We'll round to the nearest tenth. All right, the other thing is if I put 12 first, like 12 in the top, then the 7 has to go in the top too because it's from the same triangle, okay? So people do the proportions right, but people set up their proportions wrong all the time in these. So just be very careful with that. All right? So let's take a look at this. So the hardest part here is how are my triangles arranged? Do they look like each other? They look like one is turned, right? So they'll give you this, which means that all this means is R goes with which one? B. So R and B go together. S goes with C, and T goes with D. Okay? So if R goes with B, then RS, right here, RS, is how long? 8. And that goes with which one? BC. So 8 goes with X, which means the 5 must go with 12. Okay? So when you're trying to figure them out, that's how you do it. If this one starts with RS, then that means RS goes with BC. They're in the same order in this little similarity statement. What? I mean, yes, because you're going to have to do problems like this. So sometimes it's really easy to tell which ones go together. Sometimes it's not. If it's like a 5-sided figure and all the sides are very different sizes, it's easy to tell. This one's a little bit harder because the triangles are not that dissimilar. So then what would my proportion be? X over 8. So X goes with 8. X over 8 equals 12 over 5. All right, so I start with X times 5, which is 5X equals, what's 8 times 12? 96. How do I finish? And I end up with X equals 19.2. All right, is the hard part here the proportion? Like doing the actual math proportion? No, what's the tricky part? Lining up the right stuff. Yeah, lining up the right stuff is going to be the tricky part here. Okay. All right, so one more example problem. All right, so this is a hexagon because it has 6 sides. I'm going to visually look at this, and I'm going to say 2 goes with which one? No.
Oh, wait,
2 goes with X. Why? When you flip it over, the X is on the bottom. Okay, so then the 4 goes with 6. So then what's my proportion going to be? 2 over X equals 4 over 6. Very good. All right, 2 times 6 is 12. 4 times X is 4X. How would I finish? And X must equal 3. All right, so there's several different ways you can do it. Sometimes it's easy because they're set up exactly the same way. Sometimes you might need to use the letters. Sometimes, like John Jacob said, just flip it in your head, right? Like just turn it. Imagine that shape is turned. If this were turned, the X ends up on the bottom, and the 6 and the 4 end up in the same place. Okay, so go try these before you move. Hang on, before you move. 11, 12, 13 are right here. 14, 15, 16 are right here, so be careful when you're doing the numbers. Try all 6. If you don't have time, I'll cut you guys off in a few minutes. Okay, great job on all of those, all of you. Okay, so we are going to shift and we're going to talk about something called indirect measurement. So indirect measurement is essentially a way to measure things that are too tall for you to actually measure. So for example, if I said to you, how tall is this building? And you were standing on the ground, you would not be able to know unless you went to the top of the building, dropped a tape measure off, and you had access to do all of that, which you probably don't. So a way to do that is to use shadows and your own height, so your knowledge about yourself, okay, to figure out a similar triangle. Because when you stand, that's not your bell, when you stand, where is your shadow? It's like standing up next to you, or no? All right, you're not Peter Pan. It's on the floor, right? Well, it's not going to be in here. Why don't you really have a shadow in here? The light's not bright enough. It usually comes from where? Yeah, the shadow comes from, it's created by the sun. So we are going to talk about how to use that, how you would use a shadow to measure things indirectly. And again, indirect means you're not actually doing it. So you're not actually like taking a tape measure to measure the building. So for example, there is this totem pole. What's a totem pole? Yeah, it's like, so you build a totem pole and it's very tall. We don't know how tall. But we do know that how long is its shadow? 45 feet. So it casts a shadow that's 45 feet. And you can measure that because the shadow is where? On the floor, on the ground. All right? You also know that this man, we'll call him Bob. All right? Bob is 6 feet tall. So I'm going to label that. He's 6 feet tall. And he casts a shadow that is how long? 3 feet. So you notice then that this totem pole, its shadow, and this line right here make what shape? A triangle. So does Bob, his shadow, and this line right here. These are similar triangles because both of the shadows are coming from the same sun. So you can assume that they are making a shadow that is proportional based on the height of the person or the thing. So we can set up a proportion using the shadow and the height. Now, when I do this again, I'm going to write a little note to myself. I'm doing height on top, shadow on the bottom. You can flip them, but this is just the order I'm going to do it in. And I'm going to do the totem pole first. So what's the height of the totem pole? X. I don't know how tall it is, so I'm putting X. How long is its shadow? 45. All right. What's Bob's height? 6 feet. And how long is Bob's shadow? 3. So now I have a proportion that's going to let me figure out how tall this totem pole is because all I have to do is what? Cross multiply. What's x times 3? 3x. Why do we put the 3 first? It makes more sense. It lets you see that it's division when you have to go and cancel it out. All right, so do you have to do the 3 first? No, but I always will. All right, and then what's 45 times 6? I think it's 270, right? It's 270. Okay, so it's 270, and then how would I finish? Divide by 3, divide by 3. So x is ultimately going to give me 90. 90. So x is 90, which means how tall is the totem pole? 90 feet. Okay, so that totem pole is 90 feet tall, which we probably wouldn't have been able to measure because it looks like you couldn't climb it, and you probably shouldn't anyway because they're like sacred religious items, so you shouldn't go trying to climb to the top of it anyway. So if you want to know how tall it is, indirect measurement's a way to do it. And again, indirect measurement means we can draw a triangle from the height, the shadow, and if you connect those, and based on those triangles and your own height, shadow, triangle, you can figure out how tall things are that are too tall to measure. So in this case, let's do one together. Let's do one of these together. No, we're not. Okay, so I'm going to do number 11 together, and then you guys are going to do 12, 13, and 14 at your boards. You'll notice 11, 12, 13, and 14 do not give you a picture. So when you are doing these, what is the first thing you should do? Draw a picture. Now, we are usually on a time crunch in life and in this class. So when I'm doing these problems, I do not draw elaborate totem poles. I don't draw dramatic lawn ornaments. When I draw Bob, I don't draw like a very careful portrait of a man named Bob. I just draw 2 triangles because really when you break it down, that's all we care about. I want a big triangle and I want a little triangle. All right, and these, what? Can you wait like 5 minutes? Okay, so these triangles represent a lawn ornament that is 6 feet tall and the height of a globe that casts a 4-foot shadow. All right, so one of these is the lawn ornament. It doesn't really matter which. Like the lawn ornament is 6 feet tall with a shadow that's 12 feet long, so that should be the bigger one. So this is going to be my lawn ornament. So I'm going to label it LO. And this is going to be my globe. And I know that the lawn ornament is 6 feet tall. So where should that 6 go? On the side, right here, because this is the height. And it casts a shadow that's 12 feet long. So where should that go? On the bottom, because the shadow is on the ground. Okay? Now in my globe, the only thing I know is that it casts a 4-foot shadow. So where should that go? On the bottom, because the shadow goes on the bottom. And then I want to find the height, which means where does my x go?
On the
Side.
On the leg.
All right, so on that leg, that vertical leg. Okay, so this is my similar triangles. Do I even need a proportion here?
No.
Not really, because I can figure out scale factor. What do I do to 12 to make it 4? Divide by, so what am I going to do with 6? Divide by 3, which is going to give me 2. So x equals 2. Could I set up a proportion? Would I get the same thing? Absolutely. Scale factor, just if you can do it, if it's going to give you a whole number, is shorter. So how do you start these problems? Drawing a triangle. Shadows will always be on the ground. Height will always be going this way. All right? Try 12, 13, 14, go.